Hi, welcome to Algebra 2 Common Core. In today's lesson, we're going to be taking a look at how factors can work together and how we can rewrite an expression in factored form and also in quotient form. We'll learn a new technique called polynomial long division as well. So our first example shows just the number 15. Written in factored form, that's 5 times 3. Well, equivalently, I can write 15 divided by 5 is equal to 3. Since these are just numbers, I can't talk about the roots of the equation because there's no equation with variables. So let's go on to something that's going to be more common in our situation. X squared plus 6x plus 8. We are very well equipped to factor that now. We know that we have x plus 2 times x plus 4. So there's the multiplication or the factored form. Now I can rewrite this in quotient form by taking x squared plus 6x plus 8 and dividing by either of the factors. So for example, when I divide by x plus 4, the quotient is going to equal x plus 2. When I look back at my factored form, I can see that when I set those factors equal to 0, my two roots are going to be x is equal to negative 4 and x is equal to negative 2. So I think all of us could do that. Let's look at the next expression, which obviously is a little bit more complicated because it's a cubic expression. If I tell you, for example, that x cubed plus x squared minus 10x plus 8 has one of its factors as x minus 2, then I'm going to write x minus 2 as a factor. And our job today is to figure out what do I have to multiply x minus 2 by to get that polynomial. Or in other words, as a division, x cubed plus x squared minus 10x plus 8 can be divided by x minus 2. And again, right now I just gave you that factor of x minus 2. We're going to talk about where that comes from. And we will see that I don't yet know the quotient, but I have to have a technique for finding that quotient. In the above examples, I can see that to get that quotient, I'm going to need to use a division. I'm not yet ready to tell what the roots are because I don't know what the quotient is yet. But just to look at the pieces, let's make sure our terms are correct. The polynomial that I'm trying to divide, that's called the dividend. What I'm dividing by is called the divisor. And of course, the answer is going to be called the quotient. So let's take a look at the method that we are going to use to find that second polynomial, that quotient for this problem. When we want to divide polynomials, we're going to write it very much like we would have written long division of numbers. So I'm going to write the dividend, x cubed plus x squared minus 10x plus 8. And I want to show that I am dividing by x minus 2. Now when we divide with numbers, it's very important where we put the quotient based on what my dividend is. When I'm dividing polynomials, it really doesn't matter where on top I begin my answer, so don't be concerned about that part. We're going to approach this division in the same way, so we're going to say, beginning with my first term x cubed, let's divide by x. X cubed divided by x is, of course, x squared, so I'm going to put the x squared on top. Now I go ahead and I multiply and I say, what's x squared times x minus 2? X squared times x is x cubed, so I line it up right underneath the x cubed term. X squared times negative 2 is negative 2x squared. Now just like with numbers, my next line I'm going to subtract. So be sure that you're doing a subtraction there. X cubed minus x cubed, that gives me 0. But I do have x squared minus a negative 2x squared, and that's giving me 3x squared. I like to bring down my next term and then repeat the process. So I'm going to say 3x squared divided by x. That's going to give me a positive 3x. So 3x times x is 3x squared. 3x times negative 2 is negative 6x. Go ahead and do that subtraction. Once again, the first term should cancel if I've done that correctly. Negative 10x minus a negative 6x is giving me a negative 4x. I bring down the next term, positive 8. Go through the process one more time. Negative 4x divided by x gives me a negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 2 is positive 8. So I'm going to subtract that polynomial, in this case a binomial, and I see that I get a remainder of 0. What that tells me is that my original expression, x cubed plus x squared minus 10x plus 8, could be rewritten in factored form as x minus 2 times the quotient x squared plus 3x minus 4. Now that's quadratic, so that tells me that I could possibly factor it. And in this case, I see that yes, it is factorable as x plus 4 times x minus 1. Now since we're looking for the roots, we want to set that equal to 0. Making my t-bar, I get the 3 roots. X is equal to 2, x is equal to negative 4, and x is equal to positive 1. So back up in the box, I'm going to fill in. I've already got my answer of x equals 2. So my other 2 roots are negative 4 and positive 1. And again, we've done a lot of work in then transferring that over to a graph to see what our graph of this function would look like. Now let's take a quick look back at doing a division with numbers again so that we can see how the pieces all fit together. So if I wanted to divide 1,519 and I wanted to divide it by 7, it would look something like this. 7 goes into 15 2 times. 2 times 7 is 14. When I subtract, I'm getting a 1. Bring down the next digit, which is 1. 11 divided by 7 is 1. 1 times 7 is 7. Subtract and get 4. Bring down the next digit, which is 9. 49 divided by 7 is 7. 7 times 7 is 49. So when I subtract, I get a remainder of 0. When I see that the remainder is equal to 0, what that tells me is that 7 is a factor of my original number, 1519. 7 went in evenly, the remainder was just 0. Let's go ahead and try the next one where I now have 1522 and I want to divide that by 7. 7 goes into 15 twice. Subtract and get a 1. Bring down the 2. 7 goes into 12 once. 1 times 7 is 7. Subtract and get a 5. 52. 7 goes into 52 7 times, but 7 times 7 is only 49. So what that shows me is that I do have a remainder this time that's not 0. So if there's a remainder that's non-zero, that tells me that 7 is not a factor of my original number, 1522. So we're going to use that idea as we move on to polynomial division. So it's really important to take a look at the remainder, and if there's no remainder, then I know that my divisor was a factor of the dividend. If there's a remainder that's not 0, then that tells me that I do not have a factor of the dividend. So going through the division process again, we're going to practice a few times today together, and then you're going to have a chance to do some you-try-its so that you are ready to practice in class tomorrow. So make sure you're practicing with me and listening to every step of the way. So I want to divide 2x squared plus 15x plus 20 by x plus 6. So I always write the numerator divided by the denominator. Start with that 2x squared and say, can we divide 2x squared divided by x? That's going to give me a 2x. 2x times x is 2x squared. 2x times 6 is plus 12x. Subtract this line from the first line and I get 3x plus 20. Divide again, so 3x divided by x is 3. So you can again see why it really doesn't matter where I'm putting those terms on top here. I could have started over here and it doesn't matter at all with polynomials. 3 times x is giving me 3x. 3 times 6 is giving me plus 18. So when I do this subtraction, I'm getting a remainder of 2. So the remainder there, I'm going to look at this in two ways. First of all, since there's a remainder, that tells me that x plus 6 is not a factor of my original polynomial 2x squared plus 15x plus 20. Now I can also write down the quotient. So I can say, okay, when I divided this, I got 2x plus 3. But since I had a remainder, my remainder of 2 would then be written over x plus 6, which is that divisor. So this would be the answer for the quotient, or for the division problem. Now example 3 is a very similar problem. You'll notice a correspondence with the terms that we used in the previous example. So 2x squared plus 15x plus 18, I want to divide by x plus 6. So 2x squared divided by x, that's 2x. 2x times x is 2x squared. 2x times 6 is plus 12x. So I'm going to subtract that. And my 2x squareds cancel, so 15x minus 12x is 3x. Bring down the plus 18 and divide again. 3x divided by x is 3. 3 times x is 3x. 3 times 6 is plus 18. Subtracting, I see that I have 0 remainder this time. So this one is slightly different than my last example. So first of all, since there's a 0 remainder, this then tells me that x plus 6 is a factor of my original polynomial, 2x squared plus 15x plus 18. It also tells me that when I write down my quotient is just the binomial 2x plus 3. There's no remainder left, so my answer is just the binomial 2x plus 3. Now we'll find in example 4 that this process is really no more complicated, even though I'm starting with a higher order polynomial. So this time my dividend is 8x cubed minus 10x squared plus 23x minus 25. And I'm dividing by 2x minus 3. So start with the first term, so I'm going to say 8x cubed divided by 2x. That's going to be 4x squared. 4x squared times 2x is 8x cubed. 4x squared times negative 3 is negative 12x squared. Subtract both terms. Now make sure when you're subtracting you're changing the sign of the second one. So negative 10x squared minus negative 12x squared is going to give us a positive 2x squared. And again, the 8x cubes canceled. Bring down the next term, plus 23x. 2x squared divided by 2x is x. X times 2x is 2x squared. X times negative 3 is negative 3x. Subtracting, I see that now I have a 26x. Bring down the minus 25. So 26x divided by 2x, that's giving me plus 13. 13 times 2x is 26x. 13 times negative 3 is negative 39. Subtract this, and I have 14 left over. So again, that 14, because it's not 0, that's the remainder for this problem, for this division. So that tells me that 2x minus 3 is not a factor of the original polynomial 8x cubed minus 10x squared plus 23x minus 25. I can also write the quotient down as 4x squared plus x plus 13 plus the remainder of 14 over 2x minus 3. So please review the method there, because that incorporated a few more steps because I had an x cubed to begin with. In the last example that we're going to do together, I want to focus on two different things. First of all, the question is asked a little bit differently. I see that I want to know if x minus 2 is a factor of x cubed plus 2x plus 9. Well, really, that's just another way of asking the question, can I divide by x minus 2 and get a remainder of 0? So I do have to do a division. Let's put that x minus 2 on the outside of my division because, of course, that's a divisor. When I look at the dividend, I need to be a little observant here. And I notice that this time I'm missing one of my terms. So I'm going to write down x cubed, but I see that I don't have an x squared term. So I'm going to hold a place for it by putting 0x squared underneath the division bar. Keep going with the rest of the terms, so plus 2x plus 9. Now we can proceed with our division. So x cubed divided by x, that's x squared. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Subtract both terms, giving me a 2x squared. Bring down the next term, positive 2x. 2x squared divided by x is 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. Subtract again. 2x minus negative 4x is 6x. Bring down the plus 9. So 6x divided by x is 6. 6 times x. 6 times negative 2. Subtracting, I see that I have a 21 left over as my remainder. So since I have a remainder that's not 0, that of course tells me that x minus 2 is not a factor of the polynomial x cubed plus 2x plus 9. So that's one way to tell whether I have a factor or not. We're going to talk about the other way in lesson 14 in a couple days. Now what I'd like you to do is turn to the two you try it problems and give them a try, and then come back after you've paused the video and worked on those two problems. Come back and check with my work and see if you got the same exact quotients, and also tell whether we've got factors or not factors in each example. Welcome back. Each of my answers are boxed in red. You'll notice that both of them ended up with a remainder, so in both cases I didn't have a factor of the original polynomial. If you need to, pause the video for a few minutes and compare your work with mine and see if you got the same work line by line if your answers don't match up. Please come and see me in the morning if you have any questions. Otherwise, we'll be practicing some division by polynomial long division in class tomorrow, so be prepared to do this work tomorrow. Have a great night, and we'll see you next time. Bye-bye.